Here's a new riddle for you. If 7 people meet each other and each shakes hands only once with each of the others, how many handshakes will there have been? Pause the video. There will have been 21. I'm sure in pre-calc honors that was no problem for you. I'm confident you got that right. Alright, well, let's go ahead and get into it here. 6.1 notes, and we're in a brand new chapter. And I wanted to just kind of take a moment and outline the near future, in fact, the end of the first semester and on into the second semester, in fact, well into the second semester, what we're going to be doing. And just a little bit about what we've already done. So if we think back, we've already talked about functions. We went into polynomial functions and their applications. We got into rational functions and their applications. And then see if you can remember what we did next. We did exponential, and then we did log. So keeping in mind this, mainly before we get into calculus, everything that we were talking about in pre-calc honors relates to a function. Okay, and this is no different. When we get into chapter 6, we've already covered these functions here. We're going to get into trigonometric functions, sine, cosine, tangent, and the reciprocal functions as well, cosecant, secant, and cotangent. And we're going to be working on this, like I said, the rest of this semester and then well into the second semester. We're going to start off, though, not really saying anything about trig other than what we're going to be doing in section 6.1. 6.1, we're really only going to be focusing on angles and their measure. Okay, because if you don't have a good idea of what an angle looks like, positive angle, negative angle, degrees, radians, if that is something you're struggling with, then you're going to struggle throughout the, like I said, for the next probably 4 months, 5 months even, into the heart of trigonometric functions. So, that being said, today we just have a few objectives. We're going to be drawing an angle in standard form. We're finding the arc length of a circle, converting from degrees to radians, and then finding the area of a sector. And we're going to define what those mean here in just a bit. So let's go ahead and get started. We're going to, if you notice the way these slides are laid out, first slide is in the top left, and then the second slide will be over here in the top right. So angles and their measure. Just going to talk a little bit about the vocabulary of angles. And initially, so the initial side of an angle, usually we talk about the initial side of an angle being the x-axis, and the terminal side of the angle is where the angle ends. Okay, so we have the initial side and the terminal side, and we have the vertex right there, in which these are probably terms that you're familiar with. When it's important as well, when we think about the positive angle, we're talking about rotating the angle, or the initial side, counterclockwise. Okay, and then we draw the angle. So degrees or radians, we'll talk about that. If the angle happens to be a negative angle, then we're going to be starting here at the initial side and then rotating around a certain number of degrees or radians in the clockwise rotation, and that's how we measure a negative angle. We'll get into some examples here in a second. Okay, counterclockwise rotation, sometimes the angle is so big that not only will you go all the way around, but then once you get all the way around, then you just keep going. And so the initial side and terminal side might be the same for an angle. Let's say it's a 30-degree angle over here. And let's go ahead and fill that in. Let's just say that this is a 30-degree angle. You would go up 30 degrees. But if you think to yourself, what would the angle's measure be if we ended up at the 30-degree angle? Now, if you go all the way around and then past the initial side, the angle can't be 30, but the end of the angle would be the same. So the 30-degree angle would be the same as a 360-degree plus 30-degree angle. And so we would say that angle measure is 390 degrees. And so it's okay to have an angle measure that's smaller, or sorry, bigger than 360. And if you do, you just go all the way around and then you just keep going. Okay, again, that's a positive angle, and you would do the same if it's a negative angle, like negative 390, and you go opposite direction, and then you just keep going past the initial side. Okay, so most of what we've just talked about is probably something you already know, so I'm going to go ahead and move on. Alright, and we say that theta, that's what that symbol is, that's theta. Theta is in standard position. Theta is in standard position, and theta is in standard position if theta is negative. Theta is positive over here on the left. Theta is negative over here on the right. And we can see theta is in standard position. That's what that means, where the initial side is aligned with the x-axis, and the vertex is right there at the origin. So that's where we get our standard position for our angles. And that's basically what you're used to, so no big deal yet. Okay? And scooting on over here to slide 4, theta lies in quadrant 2, theta lies in quadrant 4, and so the quadrants, you already know that as well, hopefully, or maybe we're just reviewing here. 1, 2, 3, and 4, so we want to be able to talk about what quadrant is the angle in. Same thing, no matter what, you've got 1, 2, 3, and 4 counterclockwise. Okay, starting with 1, where both the x and the y are positive, and in the quadrant 2, the x is negative and the y is positive. Quadrant 3, both x and y are negative, and quadrant 4, the x is positive and the y is negative. Okay, so quadrant 4 here, theta lies in quadrant 4, theta lies in quadrant 2. Alright, cranking right along. Terminal side, initial side, so if the angle is 360 degrees, so some special angles. Angle is 360 degrees, it would look like that, where both the initial side and terminal side are lined up. A 90 degree angle is just a right angle, so we already knew that. And a straight angle is basically when the measure of the angle is 180 degrees. Okay, so if you're just sitting there saying, okay, Mr. Hawks, I know this stuff, well, that's great, that's awesome. Then go ahead and pause the video now and draw these angles. And if you are thinking to yourself, oh, I'm looking at that, how do you draw a 45 degree angle and in standard form, then maybe watch me draw the first one, and then you can draw the rest of them. Either way, pause the video when you see fit. Okay, so 45 degree angle, draw this, and then terminal, so it's the initial side, vertex, and then you label it as 45 degrees. You don't have to be perfect, you just have to get it close. Okay, but make sure you label it. A negative 90 degree angle would look like that. Okay, you just go, so you rotate clockwise from the initial side 90 degrees. Okay, so that would be a negative 90 degree angle. 225 degree angle, let's see. So 225, we know that 180 is all the way around to the other side. 180 and 45 would be about like that. So maybe I'll draw a different color there. So that right there would be negative 225 degrees. Okay, and just to be consistent, let's get arrows at the end of those because I don't want to throw you off. Now 405 degrees. Let's do this. Let's subtract 360 from that and we'd get 45 degrees. So a 405 degree angle would be go all the way around and then plus 45 degrees more. And the way you would draw that, it was just go outside the box here. We're going to go all the way around. Oh, I thought I had my red. And then up to about there, and that's where 45 degrees there, but that would be, you have to do that out here too. Don't write 405 in there. Write 405 degrees. Just like that. So there you go, drawing an angle. I'm going to stop there and get to the next page in the next video. Did I answer your question? Yeah. Okay. So hopefully everything's just peachy right now. Everything's great. and I'll see you in the next video.